Good morning or good afternoon. Today we'll be recording a video on quizzette 623 for my highly accelerated class. If you're in another 6th grade class, it probably has a different code on the top. Please put your last name, comma, first name, today's date, and your class color. Today I'll say that I'm purple. All right, number 1 says, there is a proportional relationship between the number of plates Lila makes, X, and the amount of clay she uses in pounds, Y. What is the constant of proportionality? Write your answer as a whole number or decimal. And then it has a blank and it says pounds per plate. All right, so when you have a chart like this, or I'm sorry, not a chart, a graph, and it goes through 0 and it's a straight line, that's considered to be a proportional line. That means that for every few that you go up on the graph, you'll go the same amount to the right on the graph or to the left on the graph. So it's like a pattern. Now, if we look here, there's a 1 right here. So for every plate, go up on the axis, on that like really light line. And if you notice, it intersects with the line at 0.4. So that means for every 4 pounds, you have 1 plate. And coincidentally, when you go up 2, you'll see that it intersects with 8. All right, so the 8 represents your Y axis, so 8 pounds for 2 plates. So if you notice, there's a pattern. For every 4 that you go up, you go 1 to the right. So that's the constant proportionality. That's the slope, and that's the unit rate. So in 7th grade, it's called unit rate. It's also called constant of proportionality. In 8th grade, it's called slope. I just want you guys to see that the line intersects. How do I explain this? Let me see. For every Y value, there's an X value, right? There's a pattern. And the pattern is 4 over 1, or just 4 pounds per plate. So 4 pounds per plate. And since it's changing by 4 every time, because if I reduce 8 over 2, that's going to equal 4 as well. So my equation is always changing by 4. The slope is always changing by 4. The unit rate's changing by 4. So my equation would be Y equals 4X. That's my equation. Because the equation is always changing by 4. The equation for a line is actually this over here. Y equals mx plus b. That's 7th grade material. The 6th grade material, they just want a simple line that starts at the origin. So they actually give you a simpler equation, which is y equals mx. And the thing that you have to worry about is to find the unit rate, which is m, and it's also the slope. So here we found our unit rate, which was 4, and that's why I just plugged it in right here. So the equation is y equals 4x. Now number 2 is actually a 6th grade standard, and this is applicable to 7th grade curriculum and heavily applicable to 8th grade curriculum. You need to know how to label axes on the Cartesian plane. So this is quadrant 1, if you didn't know that already. So this is quadrant 1. I'm writing it in blue. This is quadrant 2. This is quadrant 3. And lastly, this is quadrant 4. Those are just Roman numerals. On your paper, I don't know if it copied it legibly, but I want you to notice that there's a bold line right here. I'm doing it in red. That represents 5. This line right here that I'm writing on, that also represents 5. That intersects at the y-axis. This is considered to be 5 as well. There's 4 of them, and then this is the last one. So if you're trying to find the coordinates of the moon, for instance, like this one right here, you would notice that it's on this 10th line, so you know that it's going to be on 10. Same with K. If you look at K, this is going to be at -5. That way you don't have to sit there and count every single time, like 1, 2, 3, 4, 5. You just know that, oh, that's -5, so there it is. Okay, so it says determine the coordinates of each figure. The lightning. So I found the lightning. It's right here. It's right on top of the x-axis. If you forgot, this is the x-axis and this is the y-axis. That never changes. If you ever have a Cartesian plane, it's always going to be x is the horizontal line and y is the vertical line. So the coordinates of this lightning are at 1, positive 1, comma 0. Also, something for you guys to note, I'm going to write this in, let me see, I'm going to try to get a different color. I'm going to write it in purple. In the first quadrant, the x-axis is positive and the y values are positive. In the second quadrant, the x values are negative and the y values are positive. In the third quadrant, both the x values and the y values are negative. So if you have the triangle, the coordinates of the triangle, both of those coordinates are going to be negative. And lastly, in the fourth quadrant, the x values are positive and the y values are negative. And as a reminder, when we write a coordinate, we always write it x, comma, y. So I notice here, I'm going to explain this just a little further. So the lightning is actually on top of the x-axis. So look at where it's at first in terms of the x-axis. So in terms of the x-axis, here's 0, that's the origin, and it's next to 0, which is it's exactly at positive 1. So that's going to be positive 1, and then look at what direction it's at in terms of the y values. In terms of the y values, it's at 0 in terms of y. So that's why I put 1, comma, 0. And they're both positive because technically if it's here, it's going to be positive, positive. All right? Now the music note. The music note is located, let me see where the music note is. I'm going to highlight it. There it is. It's right there. So I just highlighted it in purple, the music note. So the music note is in the third quadrant, and I already know that in the third quadrant, I'm looking at this right here, both the x values and the y values are negative. So I can already put my coordinate as a parentheses with a comma, and I already know both values are going to be negative. So now let's look at the x values first. So let's look at x. So we have 1, 2, 3, 4. Wait, I only needed to go over 1. So that's at negative 1 for the x values. And then for the y values, from this point, how many did I have to go in the negative direction on the y value? 1, 2, 3. So it's at negative 1, comma, negative 3. Now let's look at the red x. The red x I'm going to highlight in yellow. And I know that in the fourth quadrant, my x value is positive and my y value is negative. And I can also tell because when I go on the x-axis to locate the x, I have to go in the positive direction. 1, 2, 3, 4, 5, 6. Yep. So 6, positive 6, comma, negative, let's see, positive 6, comma, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's at positive 6, negative 9. Something I want you to notice is that for Tuesday's Quizette, you have the graph right in front of you. But for Monday's Quizette, you have the graph right in front of you. For Tuesday's question, you also have the graph right in front of you. We have Robbie is assembling prize baskets for a raffle. The number of prizes that were donated determines the number of baskets he makes. So the key word here is the number of prizes that were donated determines the number of baskets he makes. So P is the number of prizes donated. B is the number of baskets Robbie makes. So the second variable sounds like it's dependent on how many prizes are donated. So independent means that it's not depending on anything else to produce what it needs. Dependent means it's like it has to rely on something else in order for it to work. So it says here, which of the variables is independent and which is dependent. So P would be independent and B would be dependent. And I am over here stressing out about how if I'm explaining this correctly, and it's right here, the definition. It says there are two variables. When there are two variables, one is called the independent variable and the other is called the dependent variable. The variable whose value does not depend on the other is considered independent. So the one that doesn't depend on the other one is independent. The variable who depends on the other is dependent. Go ahead and reread that a couple times to yourself. And after a few examples, you might be able to understand what it's asking. But on the back, you guys have it on Wednesday, but then on Thursday and Friday, it says determine the coordinates of each figure. You're going to use the same picture. So you're going to use, for number 2, you're going to use that picture. And for number 2 on Friday, you're going to use that picture as well. All right? It's just that I didn't have room to copy it each day. So I just made it a little big on Wednesday so that you guys could still see it for Thursday and Friday. All right, going back to the first page.